here we go. The Big Bang Theory. Well, what the heck is it? Is it? No, it's not the theory of me smacking the board. The Big Bang Theory states that at one time the entire universe was confined to a dense, hot, supermassive ball. And then about 13.7 billion years ago, the violent explosion occurred, hurling the material in all directions. Okay. All the universe was at one point in one tiny little spot. I've heard it described as different sizes. They don't know, so it's a small spot. We're going to go with small spot, either a ball or a size of a teaspoon or a marble. I've heard it all. Okay. The whole idea, though, is that all the matter that we have as we know it was either all in one spot or it wasn't even there. And then it goes kaboom, and now it's very violently spreading out throughout the universe. Okay? It starts out really, really, really hot. And as it starts out really, really hot, it starts to cool down. As it cools down, like 500 million years later, however long that is, as it starts to cool down, it starts to form solar systems and stars and planets. These first stars and planets are really, really big. They're really big. They don't live very long. These really big stars don't live very long. And then you get a few generations of stars later, and then you have the Earth. So Earth, the Sun, the Earth, like third or fourth generation star. That's the Big Bang Theory, in a nutshell. So, Big Bang Theory. Well, this is a theory, that's a great theory. What evidence do we have for this theory? Well, we actually have some decent evidence that points in this direction. The first piece of evidence we have is called Redshift. The second piece of evidence we have is cosmic background radiation. I'm going to talk about the radiation first, so I can spend more time to talk about redshift. Okay? Whoa, what is this? Red. Okay, you guys might not have caught Lily, who walked in to class today. Lily knows how much I like to cook and how much I like to make weird things like ice cream. And she got to enjoy my ice cream last year. One of the other things I love to do is bake. Love making bread. When you make bread, you get a whole bunch of flour, water, egg, sugar, yeast, mix it together, and it makes this really gooey substance called dough. So, well, this particular person was making raisin bread, and raisin bread, you put a whole bunch of raisins in your dough. And when it's in a dough form, like if you're making cookies, everything's really compressed together. But when you make bread and you let it rise, and you let the yeast do its work, the bread starts to expand. Okay? If you ever had bread that's really doughy and really heavy, just kind of makes your stomach hurt, compared to bread that's really light and fluffy like a croissant, okay? That one has expanded a lot more than a heavier bread. Okay, here we go. Raisins, 2 centimeters, 5 centimeters apart. As it expands, look at this, that expansion opens. I apologize for not having a really fun exercise. I was going to have, grading, it's really killed me. I didn't get to do the fun thing. I was going to do balloons. You get these balloons, like the big party balloons, and you cut out little pictures of galaxies and stuff, and you tape it to the balloon. You tape it all over the balloon. Okay? Now the balloon is completely covered with these little galaxies, but then you blow the balloon up. And now where are the galaxies? Are they touching each other anymore? No. Now they're all expanded. Okay, so this shows universe expansion. We see everything moving away, and this causes the light to do what?
Expand.
With what kind of a shift?
Redshift.
Redshift. Okay, so, and then you get to eat your delicious raisin bread.
What was that?
Oh, I only have one more slide. How exciting is that? Yeah.
Woo!
Okay, this. Okay, what I have just spent the last about 20-30 minutes explaining is what is the Big Bang and what supports the Big Bang. Jasmine?
Are you ready for this?
Yes, write this. Big Bang has got some problems. Like all theories, it's not perfect. It doesn't work on all fronts. We still don't understand the universe enough to know exactly what's going on? Okay, Big Bang. If the universe started with the Big Bang, gravity always wins. Okay, with the death of a star, gravity always wins. The universe does not play by the rules of our Big Bang theory. Eventually, if you have an explosion, it will start out fast and then start to slow down as it dissipates. That's just how physics and things work. However, the future of the universe follows two possible paths. It will expand forever, or if it follows gravity, the outward expansion will stop, gravity contraction will follow. Do you remember what was the big thing driving solar nebula theory? Gravity. Gravity pulls the nebula, it contracts, it condenses, it spins, right? All from gravity. Eventually gravity should win, or it will expand forever. Well, Big Bang Theory says it should eventually come back together. But it's not. In fact, it should be slowing down. It's accelerating. It's getting even faster and faster, based off the data that we have. What's going on with that? We don't know. That's the best part. And scientists have invented a word to explain what's causing the universe to expand even faster and faster when it should be slowing down. They call it dark energy. What is dark energy? The universe is speeding up, speeding up, speeding up, speeding up. We don't know why, but physics tells us that if something is to speed up, a force has to be acting upon it in order for that to happen. So somewhere in there, there's energy that's causing it to accelerate. We can't see it. It's dark. We don't know where it comes from. We don't know anything about it at the level we're at. Okay, we don't know anything about it. So it's dark energy. There's also dark matter, where there's matter that's affecting gravity that we can't see. We're not going to deal with that. Okay, but dark energy. So does the Big Bang Theory, does it answer every question? No, but it answers a lot of the questions. And if we're dealing with just a pure science and data viewpoint, because that's what scientists do, is just they can only deal with things that we can test. We can only test things that we can test. That makes sense. Just to me. Then this is what we have. Does it answer every question? No. And, okay, it should be noted, however, that the methods used to determine the ultimate fate of the universe have substantial uncertainties. We only know so much. So that's the Big Bang Theory in a nutshell. Everything was at a very supermassive small point, boom, it expands. It's expanding, expanding, expanding. It should be slowing down, but it's not. We see the expansion in what? Redshift. And we see the leftover energy of the original explosion in
Blue ship.
background radiation. That is, in a word, the Big Bang Theory.